Hi everyone, welcome back to my channel. In this video, we will discuss about the second shifting theorem of Laplace transformation. Now, before going to the theorem, let me recall the definition of Laplace transformation. So, suppose we have a function f of t, then the Laplace transformation of f of t is given by the integral 0 to infinite e power minus st f of t dt. Okay. Now, before going to the second shifting theorem, we need to recall a function which is called unit function, unit step function, or Heaviside function. So it is denoted by uct or u of t minus c, which is defined as 1 if t is greater or equal to c and 0 if t is less than c. So now let me state the second shifting theorem. The theorem has two forms. Both forms are equivalent. So let me write that. So first one is Laplace transformation of u of t minus c into g of t minus c is equal to u of e power minus cs Laplace transformation of gt. And the second one is Laplace transformation of u of t minus c into gt is e power minus cs into Laplace transformation of g of t plus c. So both forms are equivalent. So we will use the forms accordingly. Okay. So let me take some example to understand the theorem better. So the first example is, suppose we have given the function f of t is equal to e power t minus 3 if t is greater or equal to 3 and 0 if t is less than 3. So note that we can write this function as e power t minus 3 into 1 if t is greater or equal to 3 and e power t minus 3 into 0 if t is less than 3. So we can write it as, we can take common if e power t minus 3 times 1 if t is greater than or equal to 3 and 0 if t is less than 3. So basically if t is nothing but e power t minus 3 into u of t minus 3. So here we have c equal to 3 and gt is equal to e power t. So here we use the first form, this one, right? C equal to 3 and g of t is equal to et. So what is the Laplace transformation of gt, which is L of et, which is nothing but 1 by s minus 1. So what will be the Laplace transformation of e power t minus 3 ut minus 3 is nothing but sc is 3, so e power minus 3s into L of gt, which is s minus 1. So it is e power minus 3s by s minus 1. Okay, now let us take the second example. So we have to find the Laplace transformation of ft, where ft is cos t minus 2 pi by 3 if t is greater or equal to 2 pi by 3 and 0 if t is less than 2 pi by 3. So note that here also we can write it as cos t minus 2 pi by 3 times 1 if t is greater or equal to 2 pi by 3 and 0 if t is less than 2 pi by 3. So it is nothing but cos t minus 2 pi by 3 times u of t minus 2 pi by 3. Here also we use the first form of second shifting theorem. So here we have C is equal to 2 pi by 3, gt is equal to cos t. Now we know that what is Laplace transformation of gt? It is nothing but s by s square plus 1. Okay, so we have Laplace transformation of cos t minus 2 pi by 3 times u of t minus 2 pi by 3 is e power, yes, c is minus 2 pi by, 2 pi by 3, so 2 pi by 3 s and into Laplace transformation of cos t, which is s by s square plus 1. Okay. Now we'll take an example which we will find the Laplace transformation by the second form of second shifting theorem. So we have to find the Laplace transformation of the function ft, which is nothing but t square if t is greater than or equal to 6 and 0 if t is less than 6. So we can write this function as t square times 1 if t is greater than or equal to 6, 0 if t is less than 6. So we have t square times u of t minus 6. So here we use the second form of second shifting theorem. Laplace transformation of u of t minus c times g of t is equal to e power minus cs into Laplace transformation of g of t plus c. So here note that we have c is equal to 6 and gt is equal to t square. Now we need to find Laplace transformation of g of t plus c. So what is g of t plus c? So g of t plus c means 6. So t plus 6 is nothing but t plus 6 whole square, which is t square plus 12t plus 36. So by the second shifting theorem, L of t square into u of t minus 6 is nothing but e power c means 6 minus 6s into Laplace transformation of t square plus 12t plus 36. So that will be e power minus 6s. The L of t square is nothing but 2 by s cube. L of t is 1 by s square, so it will be 12 by s square. And Laplace transformation of 36 is nothing but 36 by s. So that's how we find the Laplace transformation of this kind of function. If you like the video, then please like, comment, and subscribe. Thank you.